Hello friends, in today's class we'll discuss about a very important topic which is resistors. So what is resistor, why this is so important, what are the types of resistors, we'll discuss in today's class. And also we'll see the interconnection between memory and processor in today's class. Whenever we run any program, how these instructions are executed with the help of memory and processor with the help of different resistors. We'll see all these things in today's class. Let's start. Before we start discussing about the topic of today's discussion, which is resistors, let me ask you a very simple question to you. If I ask you, what are the types of memories you know till now? Now most of you will say or will answer, sir, we know about primary memory, we know about secondary memory. Again, in primary memory, we know about RAM and ROM, right? Yes, your answer is correct. RAM, ROM, primary, secondary, these are very important topics or important things in computers. But remember, now onwards, now as you are doing your engineering course, if anyone asks you about the types of memories, we won't only say about primary and secondary. The major types of memories we'll focus in our engineering course are primary memory, secondary storage, then cache memory, and finally we have resistors. Fine. So now from this discussion, initial discussion, at least now you know that resistors are nothing but a type of memory. What type of memory we have is resistor is? Resistors are nothing but the smallest memory we have in the system which can hold anything temporarily. But the storage size is very, very small. And resistors are the fastest memory we have in the system. Fine. Now about all these types of memories like primary, secondary, cache, and also resistors, in future classes we will discuss about all these memories very well. We have separate discussion on that. So let's start the topic of today's discussion, which is about resistor. Initially we will start with resistor, then we'll go on. So what is resistor? We already know. Next is, there are two major types of resistors we have. One is called general purpose resistor and second one is called special purpose resistor. Now I think you already know about some general purpose resistor like R0, R1, R2, R3, etc. You already use these resistors, right? General purpose resistor, from the name itself you can guess the purpose of these resistors are general purpose, means we can use for any operation. Now what are the operations it can do? We'll see in the upcoming classes. And next type is special purpose resistor. From the name itself you can guess. Special purpose means these resistors can do some specific task only. These resistors are designed to perform some specific task only. That's why we call it as special purpose resistors. Fine. Now we have many types of special purpose resistors. But if I talk about the very important special purpose resistors, then we have to remember few special purpose resistors which we will use repeatedly again and again. These resistors we will use in the upcoming classes also. What are those? Number one is IR. Full form is very important to remember. IR is nothing but instruction resistors. Next is MAR, memory address register. Next one is PC, program counter. Next is MDR, memory data register. We have some other also, like MBR is also there, memory buffer register, and we have some other special purpose registers as well. But these four special purpose registers are very important to know. Fine. Now out of these four special purpose register, in many competitive exams, even in GATE, you may get some questions on PC. The very basic question you may get: what is the main purpose of PC? Why we use PC? PC, the full form is program counter. What is the main purpose of PC? So in short, whenever we fetch any instruction from any program, PC holds the first address which you need to execute. Fine. But in execution state, if anyone asks you what is the purpose of PC, then in execution space, PC holds the address of the next instructions to be executed. Now what is address and all? We'll discuss in detail in the upcoming classes. Fine. So next, before we jump for the next topic, which will talk of, or which will tell you about the interconnection between memory and resistors or memory and processor, we should know some basic things before that. I think all of you know about different types of programming languages, right? You already have gone through C, C++, Java, Python, and so on. Now, if I ask you broadly how many types of programming languages you can have, so we can have high-level programming language, we can have low-level or machine-level programming language, right? Now, what is high-level programming language and what is low-level programming language? You already know, right? What is high-level programming language? The programming language where we write the instructions or each point like normal English, right? Human also can understand this. And machine level language or low level language is nothing but the programming language where it's very difficult for the human being to understand what the code is or what the code is all about. But machine level language can be easily understood by the machines or computers. We know that. Now, whenever we write any high level programming language, that's exactly same language our computer cannot understand. We already know that. So next, what is the alternate or what is the solution for that? We know there is an assembler which can translate your high-level programming language to machine-level language, right? So that your machine can easily understand. Fine. Now, if I ask you about some machine-level language, assembly language is one example of machine-level language. One more type of machine-level language we day-to-day life we use is RTN, register transfer notation. So about assembly language and RTN we'll see in the coming classes. So next is one example I have. See here, this is a normal C programming or normal programming I have written C equals to A plus B. Now if I write C equals to A plus B and try to execute, my computer actually cannot understand what it is. For that, my assembler will translate this C equals to A plus B into something that can be understood by machine. Means some machine level instructions, it will convert to some machine level instruction. Now how it will look like, this is just an example. If the same program I execute, my assembler will translate this instruction to a set of machine level instructions. And see the machine level instructions to perform C equals to A plus B, it will translate into something like this. First of all, it will be load R0, A. So what is R0? R0 is nothing but a general purpose register which is available in our CPU. In CPU we have many registers, some are special purpose and some are general purpose. So as I told you, general purpose register can hold anything which is general purposely used, right? So what it means? So I will load my A to R0. What is R0? A register, a hardware. So whatever they are in A, what is A? A is nothing but the memory location where the actual value is present, right? A is not the value or data. So in place of A, we'll have some data or value for that, right? Suppose A equals to 5 you have entered. So that 5 will be stored back to R0 in CPU. Is that fine? Similarly, I need B also. For B also, maybe you have entered some value. So that value will be copied to R1. R1, what is R1? R1 is one more general purpose register inside CPU. Next, what I need to do? I need to add A plus B, right? So for that, the instruction is add R0, R1. So what does it mean? Means this is nothing but R0 equals to R0 plus R1. Means whatever they are inside R0 and whatever they are in R1, we have to add both, and finally we will store the result in R0 again. Fine. And finally what I have to do? I have to transfer back the final result A plus B to where? To a memory location C. Fine. What is that A, B, C is? We don't know. This is just a random example, right? So whatever, it may be 1024, it may be 526, any memory location or memory address. So where I will store it back. So store R0 C is nothing but whatever they are inside R0, I will storing back or sending it back to location C in the main memory. So once it is back in the main memory, the user will get the result. Fine. This is how the instructions are being transferred or translated to some machine level instructions. Fine. Now we will see the interconnection between processor and memory. Whenever you run some program, actually how it works. We'll see all these things slowly. So here I have drawn a figure diagram where I have memory this side and this is nothing but the CPU. Inside CPU, I have shown the major components. What are the major components I have shown? CU, we already know CU is nothing but control unit, a very important hardware in CPU. Then we have ALU, arithmetic and logical unit. So apart from CU and ALU, what I have done is I have written down some of the most important registers here. So what are the important registers I have considered here? MDR, which is memory data register, MAR, memory address register, PC, program counter, IR, instruction register, and there are several general purpose registers, right, like R0, R1 and so on. Fine. And if you see the connection, this MDR to memory, it's a two-way connection. CEU to memory, it's a two-way connection. From MAR to memory, it's a one-way connection from MAR to memory. So what is CU? We already know. What is ALU? We already know. What is MDR? MDR is the special purpose register which is responsible to transfer data either from CPU to memory or from memory to CPU or in any other registers, right? MDR will be holding the actual data and it will transfer the data. It can transfer the data to memory also, and it can take from memory to CPU also. Next we have MAR. The full form is memory address register. So what is the basic purpose of MAR? MAR will send forward the memory address, the particular memory address from where I need the data. Suppose this A is, the value of A is present in some location 1024 and I want to execute this. I want the data from 1024 location. So who will transfer this address? MAR. MAR will tell my memory that please send the data whatever present in the location number 1024. Fine. Now about this memory arrangement, how memory looks like, we'll see all these things in the upcoming classes. So as this is one of the introductory classes, so please don't take so much of headache. We'll discuss all these things, how actually memory location works. Fine. Next we have program counter. I told you in the instruction fetching, it will hold the first memory location where I have to go, and in execution mode, it will hold the address of the next instructions to be executed. We know that. Fine. I think this communication or this block diagram is fine for you. Now we will take one example and we'll try to explain how it actually works. Same example I am taking, C equals to A plus B. Suppose C equals to A plus B is translated into machine level instructions already, which are load R0 A, load R1 B, add R0 R1, store R0 C. And these instructions are saved in some memory locations. Obviously, whenever you translated something, you want to store it somewhere, you need memory, right? Once you store, then only you can get the things. So all these instructions will be saved or stored to your main memory only. So in your main memory, in the location number 1000, the first instruction is saved. Similarly, in 1008, second instructions, then 1016, third instruction, so on. So you have total 1 to 4 instructions to be executed. All these 4 instructions are stored in main memory like this. These are some random memory locations I have taken. So in upcoming classes you will learn everything, how to choose the memory location also. Now all these instructions are ready in my memory, so it's there inside memory. Now I am ready to execute the program. So now in instruction fetching, I told you whenever instructions are fetching, PC will hold the first address of the memory location where your instructions are present. What is the first address we have? 1000. So currently your PC is holding 1000. Fine. This 1000, whenever you are in execution mode, you just hit the run button. It means your program is ready to run now. Now your PC will hold the address of the next instructions to be executed. What is the next instructions to be executed? 1008. 1000 is the present address and 1008 is the next address where you can get the next instruction. Now your PC will hold the address of the next instruction to be executed. So once you hit the run button, this 1000 which was previously there in PC will be transferred to MAR, and 1008 will be holding by PC, which is the next instructions to be executed. Now MAR will transfer this address to memory and will say that I got some memory address from PC which is nothing but 1000. I don't know where it is and what is there inside 1000, but please, whatever they are in memory, please forward it to MDR. I don't know what we have. Understood that? So once MAR communicated with memory with the location 1000, memory will say, yes, I have something in location 1000, which is nothing but load R not A, an instruction I have. Suppose this A is nothing but 5. I am not saying A here. A is 5 and B is 6. So now what your memory will do? Your memory will send this instruction load R not 5 to MDR. Fine. Now your MDR is having one instruction. What is the instruction? Load R naught, 5. Now this instruction next, MDR will forward this instruction to IR. The responsibility of IR is to take the instructions and decode the instructions. So IR will take the instruction. What is the instruction? Load R naught, 5. So once IR get this instruction, with the help of your CU, your IR will know that okay, I have some value 5 and I have to store this 5 to R0. What is R0? The general purpose register. So this 5 will be stored to R0 with the help of CU. IR will store this 5 to R0. Fine. So in the meantime, PC will send this next address, which was holding by 1008, will be sending to MAR. Now MAR will send this address to memory again, saying that okay, I have the next address with me, please send the data to MDR. What is the next address? 1008. Your memory will say okay, 1008, yeah, I got the location and I have something in 1008. So what is there inside 1008 location? Load R1, 6. So memory will send this address or this instruction load R1, 6 to MDR. Fine. So once this load R1, 6 is there in MDR, again MDR will send this instruction to IR that I have the next instruction, please check it, decode it and do the necessary action. So next action is to load the value 6 to R1. So with the help of CU, your IR will load 6 to R1. Fine. Next, in the meantime, obviously when 1008 was being executed, PC will hold the next address, which is 1016. Next 1016 will be forwarded to MAR, and in the similar way, your memory will send the instruction to MDR. MDR will send the instruction to IR. What is the next instruction? Add R0, R1. So whenever I get some keyword like add, mul or product, sub, means these are some arithmetic operation. So once your IR knows that I got some instructions from MDR which talk about some arithmetic operation, this is not in my hand. So we know who is the responsible for performing arithmetic operation, ALU, right? So what IR will do is, with the help of CU, this instruction will be forwarded to ALU that I got some keyword add, means you have to do some arithmetic operation, please do it on behalf of me. So now your ALU will perform the arithmetic operation. It knows how to perform addition, right? So what are the values we have? 5 and 6. So your arithmetic ALU will perform 5 plus 6, which is 11. And where I have to store back, it's already mentioned. R0, R1 means R0 equals to R0 plus R1. So now this 11, 6 plus 5, 11 will be stored back to R0. Fine. So in the similar way, next the last address will be forwarded to memory, and memory will send the next instruction, which is store R0C, and this instruction will be again sent to IR, and IR will decode this one, store R0C. So whenever your IR gets some instructions like store, it knows what to do. Store means from processor to memory. Load means from memory to processor. You understood that? If I get a keyword like load, means I know I have to get something from memory. If I get some keyword like store, I know I have to transfer back from CPU or processor to memory. So I have to send it back. Store means I have to send it back. What I have to send it back? Whatever they are inside R0. What is there inside R0? 11. Fine. So where I have to send? To C. What is C? C is nothing but some other location in your main memory. C is a variable, right? What is a variable? We know. Variable is nothing but it's a reservation for some data, right? It's a reservation in the main memory to save some data. So for C also we'll have some memory address like this. So here we have C. So which is maybe 1028. So in 1028 we will return the final result again. Fine. So I believe you understood how these registers and memory works together to perform a particular application. So that's all about today's discussion. Very soon we'll start with the next topic. Thank you everyone for watching my video.